My name is Lamia Youseff, and I'm the Executive Director at JazzComputing and visiting lecturer at Stanford Graduate School of Business. And I take my coffee with milk, espresso with milk in the morning.
Welcome back to the MLOps Community Podcast. I am your host, Dimitri Os, and today we are talking with none other than Lamia. I'm flying solo, got no co-host today, but I don't really think I needed one because Lamia was such an incredible guest, and how could you not be? Let's just give a bit of context around what she's been up to. She's been in AI and ML for the last 25 years. We dive all into that. First, she was in academia, then said, you know what, I'm going to go and make a change in the world and implement some of this stuff. Actually, I think she was recruited. She was heavily recruited because why wouldn't you be? Again, if you're that good, you got to get out there and make a change in industry. She went and worked for every single thing that you can imagine. Google, Microsoft, Apple, and Facebook. That's basically all of them right there. Boom. And now she is doing some really cool stuff around helping startups in generative AI. And so if you are one of those people that is starting something in the generative AI space or just the LLM space, you should reach out to her because she has got some incredible experience and advice. And my favorite thing from our conversation was when she talked about how she was on the Google Cloud team in the early 2010s and how her and a handful of other people created Google Cloud. That for me is like history in the making. It's recent history, but it's still history. And I found it fascinating. So we dive deep into that. We then go into what she is doing at JazzComputing and what the mission is and how she sees parallels now with the AI and ML movement to the cloud computing movement in 2011. And we finish up with what I thought took me back a little bit, but she was talking about how Kubernetes got its start, in 2015 or 2014. I can't remember the exact date, and I should know that. Again, the history part of me just goes right out the window. But she talked about how there is no real unifying layer that you get in the ML world. And so we pontificate on why that may be and how that can change. I mean, we don't have any Googles going out there and throwing their whole weight behind a certain standard like Kubernetes. Will it ever happen? I don't know. That's a big question to be solved by the community. So enjoy this one. And if you can do one thing, it would mean the world to me if you just tell one friend about this podcast so that we can continue to have it grow. Let's get into the conversation with Lamia. I'm really excited about this conversation because I feel like you have had just about all the experience, whether it has been in academia or working for gigantic companies, the ones that we've all heard of and maybe love or hate, and then also the experience working with startups and smaller companies that are maybe more resource constrained. And so I look forward to tackling all of those different areas and pieces of your life, but it's probably worth starting with how you got into the field, and specifically you started down the AI path 25 years ago, before it was cool, way before it was cool, I would say. What was that like?
Oh, it's a lot of really interesting stories. I grew up in Egypt, in Cairo. And back in the days, I remember my mom, she was working on her dissertation. And in order for her to be able to write down the dissertation, she had to handwrite it and then take it to the typewriter, the local typewriter, which is a shop in another neighborhood. She had to travel an hour and a half in Cairo traffic in order to be able to sit there beside the typewriter, the person who writes the handwritten notes down into basically a typewriter.
Oh, wow. So she didn't even write it. She had somebody else that had to write it that knew how to type.
And it was an hour in traffic, hour and a half each way. And my family at the time decided that it's time to get a computer, and it was about $10,000. Windows 3.11. We got it. It was huge. We put it in the living room at this corner. It was just like amazing, very shiny and exciting. And we were allowed, my brother and I, we were allowed to play on this computer for only 1 hour a day. And very careful, and basically keep it clean. But then we heard about computer viruses through the local newspaper that was delivered in our home, and we were like, oh no, we should be very careful. Of course, it wasn't connected to the internet. The only way that a virus could get in later on was through a floppy disk or something. But we were very careful. We were very alarmed. So every time we opened the computer, we check all of the files as much as we can, especially the ones on the desktop, until we saw a file that's called Chapter 7, and another file a couple of days later called Chapter 5. We double-click on it. We don't understand a word in it. It was a Word document. And we agreed that this is likely the viruses or a virus that they were talking about. So we start deleting it.
Oh, no.
We delete the first file. We delete the second file until a few days later when we hear our mom on the phone talking to the computer specialist saying that the computer is deleting her dissertation. That was an aha moment. What's going on? So this is how we got into computers. And I went to study at the computer science department in the American University in Cairo. And there was this young professor that came back from the US, who did his work on fuzzy networks or artificial neural networks. And after taking the introductory AI class that was talking about expert networks and expert systems and all of the more common AI concepts, I got me a student in that class, artificial neural networks, and be able to learn about the fascinating field of AI and deep learning. I remember very vividly my mom coming back from a doctor visit one of those days when I was taking the class, and she shared that the doctor suspects that she had breast cancer and she have to go through biopsy and so on. And at the same time in the classroom, we were taking our homework was to build a neural network, basically a very basic predictor to be able to predict benign versus malignant breast cancer. And in my mind, it was, wow, if we can do that using computer science and using very basic tools in my mind of being able to train a network and being able to actually possibly save lives by predicting and by being able to detect breast cancer early on, I can save my mom's life. I can save many women's life. Luckily, unfortunately, my mom, breast cancer or tumor turned out to be benign, and she's healthy. She's doing good. So it was really good. I got introduced to the world of AI machine learning. And back then, when I was writing this homework assignment, was written in C. The connection between the different neurons were C pointers. And in order to parallelize it, I had to borrow my dad's computer while he was sleeping, my brother's computer while he was sleeping, moving the code on floppy disks in order to run it. I mean, it was not connected over the internet, all of them. We had only one phone line, one dial-up line, so only one computer can be connected at a time. Wow. And being able to just run and explore the amazing space of AI and machine learning. And of course, when I have a pointer, a C pointer that didn't point to the right neuron, it's a memory dump, and the computer just restarts. So bugs were extremely painful at that time.
Oh.
And got very excited about this, became a research assistant at the time in this specific area, and decided that I want to go to the US, come here to the US in order to be able to continue the study of this fascinating field at the graduate level. However, what I found when I applied is I got the advice that AI is a dead field. Don't waste your life. Do something else useful.
What?
Wait a minute, am I confused or what? So I was like asking as a young researcher, what's the problem? Why not? And they're like, lack of computational resources. Like, okay, let me take this problem on, and then, we'll come back to machine learning later. So that's how it led to me working on cloud computing and scientific code and scientific, basically computing in the early days, getting me to high-performance computing, getting me to virtualization on cluster computing, which turned out to be one of the early days of cloud and cloud computing. So writing papers in this field, trying to share the knowledge and trying to share the landscape of how things are developing back in 2007, 2008 at that time.
Wow. So you saw from the get-go a practical application of AI and you saw that it could actually be used to help save lives. And I'm sure you've kept an eye on all of the advancements that are happening within the health field in AI and the ability that it has now. And I imagine you would have never have thought back in those days its capabilities and what it's able to do. But it's almost like that inspired you to take the plunge and then go deeper down the rabbit hole, and you found different bottlenecks along the way. And one of these bottlenecks was this compute resources. And so that got you into the cloud, and the cloud was a very new thing at that time, right? Like, what was that like? Because it's funny, in 2007, the cloud was an actual thing where there already the big players offering the cloud. Like, was AWS one of the, did they have AWS yet? I don't know the timeline on that, actually.
I think it was 2006, 2007, maybe 2006, when we were invited, some students were invited to write some code and run it on an Amazon system. They didn't tell us what's the system, it's just a remote system. And we're becoming beta tester for that system, and we're just seeing, like how it's going to work. So I believe at the time, I don't even remember what was the application, but I was kind of, like trying to find about the system through the prompt, trying to see, like where things are. And it was clear to me it was a virtual machine running on a remote computer. And then it turned out later on to be EC2. And we're just testing EC2. They didn't tell us what we were testing. We're just like basically running some basic codes. But then through the next year, we just, I became more and more interested in this capability. So at UC Santa Barbara at the time, we were working on cluster computing, and I was working on virtualization. So at the intersection of both, we built a system that's called Eucalyptus back in the days. And Eucalyptus basically is a private cloud. And we're jumping around. We're very excited because it basically, like the media, as soon as it got out in the TechCrunch world, it was like, this is the Amazon EC2 equivalent. This is, like the private cloud. This is what's going to change the world. So it was very exciting times. What all we did was to get the APIs from EC2 and from Amazon AWS and put it on top of our cluster that have virtual machine running behind it. Later on, it was integrated into Red Hat. The team decided to build a company around it. Unfortunately, I wasn't able to join them because of my role. I got the opportunity to go to MIT and to work on further research. At the time, my aspiration was to go for an academic role, and it was very hard to say no to MIT at the time. So it's definitely, they tried to take it as fast and as far as they could. Having said that, it was really early days of everything that was happening in cloud and everything that, like the ideas forming and things coming together.
What changed in you that made you not go for academia or a lifelong academia pursuit?
It was difficult to make the decision, but it was Google Cloud.
Really?
So, yeah. 2011, Google came and they told me, at the time I was in Boston at MIT, and they said, we have this exciting project that's going on in Seattle. We want you to move next weekend in order to be able to join this project. And I started asking, so what project it is? Why do you need me? What's going on? Can you tell me? And no, it's all confidential. You will know when you come. I was excited and intrigued. And so I decided to go. And my thinking at the time was, I'm going to go there for 6 months, build some research connections, learn something new, and come back to my position at MIT and basically continue my academic role. The confidential project turned out to be Google Cloud. I was one of the founding engineers over there. It was amazing. It was so much fun. Just seeing the very early stages and very early, basically, building technical capabilities that's going to take over the world, if I may say, but also be used by millions and millions of users out of the door. And building really production system that's very different than research systems. So in a research system, usually what we do is that we push the design space by introducing new ideas, writing and building a prototype, especially in system research, and publishing it with the hope that's going to be adopted and it's going to push the frontier one step at a time. Of course, you have the ability to be able to dream big and to design new things and to think about new systems. In industry, it's not about pushing as much of the design. It's more about finding and building systems that's going to scale, that's going to solve problems, that's going to have product market fit, and that's going to take us to the next level, which is something that I really enjoyed doing at Google in the very early days. And Google is such an amazing company, especially back in the days. I mean, we were 12 engineers working on Google Cloud Engine at
Just
the time.
12? No
It was,
way.
like they put us in a corner hidden under the Seattle office that happened to be under a bridge. And they told us, like if you go and talk to anyone, don't tell them that you're working on the cloud. So we're very secretive. And amazingly, I mean, basically, one of the fun stories I remember from that day, actually, Joe Beda was our head of engineering at that time. Joe Beda, who went on and built Kubernetes later on. Craig McLuckie was the head of product for the cloud engine. So Craig also was one of the founding members of Eucalyptus later on, and went on to have a lot of really good influence on the whole open source and virtualization world and container world. But one of the funny stories I remember is the team of 12 were trying to find a meeting room in that Seattle office. And we couldn't find a meeting room that's enough for 12 people. All of the meeting room was small. And our biggest concern was when the team grew to 20 people, what are we going to do with meeting rooms? It's going to be tough. Looking today, I don't know, there are 10,000, 20,000. I don't know how many engineers in the organization. I hope they have enough meeting rooms that's going to be enough for everybody.
In those days, there was no Kubernetes, right? You mentioned how Joby was part of the team. And was there Docker? Like, what were you building? There was no Docker. So, like, paint the picture of what was around and what you were building back then and how it looked.
There was virtual machines. I don't think we had containers back then.
Was this the era of, like, VMware blowing up and being huge?
Not even. I think the VMware came in the very early stages of virtualization, and because of the performance overhead back then, so it wasn't as much adapted as a virtualization technology within infrastructure. I might be wrong here, but this is my understanding. And therefore, the cloud provider, there was then the part of virtualization layer that was adopted by AWS in the early days. Then Source became a company here in the US. It was initially a research project that came out from University of Cambridge, and then basically building a very small para-virtualized layer that allowed a lot of interconnectivity between the user space and the system space underneath it, which is allowed it to be able to improve the performance and be able to provide a lot of the computational resources without adding overhead of virtualization. And actually, this is some of the work that I've done at UC Santa Barbara, studying the performance implication of this kind of para-virtualized systems. I don't remember exactly what was the stack like at Google. It has been at least 10 years at this point. So, but what I remember is that it was using all internal tooling system, including Borg as one of the systems, and trying to come up and apply internal technology from encryption. So how do we encrypt the disk? From starting the VM, how do we start the VM? How do we decrease the time? I mean, this was actually one of the features that I worked on. How do we decrease the startup time for the VM, such that when the user comes and basically, create a new VM, then boom, they have a VM started right away. We started from something like 3 minutes. We got it down into 10, 12 seconds, if I'm not mistaken. I'm sure now it's much shorter than that. But just this is one of the challenges that we had in the early days. I mean, users are not going to sit there for 3 minutes waiting for the VM to start. That was, or encryption. How do you encrypt the disk such that you can create some isolation between the different VMs that are running on the same physical hardware? So that was another challenge. Very basic challenges, but this was our world back then, which is building the small components one at a time and bringing them together in order to be able to scale to the next level.
And as you see now with the cloud and what is almost like taken for granted, how do you view the evolution from then until now? And is it, because I just think about, have we kept things that maybe didn't need to be kept, or was there pieces in that original architecture or your original designs that have stood the test of time? or has everything kind of been replaced since then?
It has evolved. So it's definitely an exercise of evolution. I remember writing this paper on 2008 on the ontology of the cloud and basically breaking down the different components. It was in collaboration with IBM Watson at that time. My mentor, Dilma De Silva, who was one of the early engineers and early folks who have built K42, one of the early operating systems that are also had a lot, where cloud had a lot of, like aspirations and inspiration from and rooting in. But in this paper, I identified basically different layers. One of them is infrastructure as a service. Another one was storage as a service, I believe. The third one was communication as a service, what I call CaaS. That turns out to be cloud networking layer. And then, basically the application layer. There was no virtualization layer over there. There was no orchestration over there between the different layers. So, basically Kubernetes did not exist back then. There was the closest that we remember from those days was basically, like a virtualized, some way of kind of, keeping track between the different VMs. Because remember, back in, we're talking 2008, 2009, the biggest cloud deployment we could imagine for a private client would be 5 VMs, 10 VMs, 20 VMs, maybe. So that was, basically how far we could go with our thinking. Until quickly, during especially my time at Google, I got to work with customers. So I moved from engineering to product management because I really wanted to know how customers are using the technology that we have built. And got to work with some of the biggest customers that were migrating back then to Google Cloud. And very quickly got to realize that actually the use cases are very different than what we thought about in the very early days. So I remember one of them was, I believe, December 2011 or 2012, when there was a big outage for AWS. And customers very quickly realized that, specifically one of the streaming services, one of the biggest streaming services that build on the cloud from the get-go, they quickly realized that actually, in order to be able to provide their end user with significant availability and always be available during Christmas times or peak times of their usage, they have to deploy on different clouds. So at the time, they were looking to migrate between AWS and Google Cloud. Later on, I went to Microsoft and I realized that they are also migrating to Microsoft. So they were building this layer in between the different clouds. And basically, that's the multi-cloud use case. And they have deployment. So one of the projects that I worked on was building a very fat pipe between the storage system at AWS and the storage system at Google Cloud in order to be able to enable them to move, I believe, 10 terabytes of data every night. At that time, 10 terabytes was, wow, can we do that?
Yeah.
So it was just, like very early days on putting together the different components and bringing it back to the end user in order to be able to build the commercial use case, the high availability characteristic that we want in a cloud, as well as the coordination and orchestration between different cloud systems that happen to be working and deployed on a multi-cloud environment.
And so you mentioned something before we hit record about how you see so many parallels with the new AI movement and the old or the early days of the cloud movement. And one that I was just thinking about as you were talking about this is the amount of time that people are willing to wait for this novel thing. People aren't really willing to wait 3 minutes to spin up their virtual machine, but they will wait 10 to 15 seconds. And it's kind of the same with their answer. If you prompt the AI these days, they're willing to wait a good 10 to 15 seconds, but after that, it gets a little old, or maybe you're not willing to do that consecutively. What are some other parallels that you are seeing now versus then?
Absolutely. Whenever I watch the whole interaction that's happening today between startups and cloud titans and the VC world and the whole ecosystem, it's a deja vu to 2012, 2013, early days of cloud. And first of all, the competition between the different cloud providers of who's going to be able to basically win the market. When in my mind, it's going to be a multi-market, and that's what we saw, a multiplayer market. And that's what we saw with cloud. So basically today we see each of the different cloud providers trying to influence their users by saying, we have the best AI capabilities, we have the best use cases, it's going to be very similar in my mind in terms of users having to use possibly several of them at the same time in order to be able to bring their application to the use case. So I'm waiting to see an orchestrator similar to Kubernetes that's also going to work with the AI workload at the infrastructure level. So that's one thing that I'm keeping an eye for.
Can we double click on that? Because that's something fascinating I was talking to a friend, Raul, about the other day, on how there's not really a unifying layer right now for these AI workloads. And it feels like you could build some kind of abstraction on top of Kubernetes to kind of abstract away all of these headaches and these 1,000 paper cuts that you get by trying to do ML workloads or AI workloads with Kubernetes. And then you have some kind of an operating system there. But what is your view on that? Because I love this idea of, there's Kubernetes, which has been super successful in DevOps, but is there another Kubernetes that we build on top that's specific for MLOps?
Possibly. If you bring together the ideas around machine learning platformization, whether it's MLflow or the end-to-end infrastructure and components, along with the cloud and how diverse the different capabilities that's being basically provided by different cloud providers in different areas or in AI-specific capabilities in this case, along with the ability to be able to scale, have high availability, low latency services in between all of these, you'll find that we need something that's unifying all of these and that can seamlessly coordinate between them. I've seen some use cases in machine learning workloads where you would take your workload and train it on GPUs, but then when you're ready to run it for inference, to put it in production, you would move back to SageMaker, for example. Or you would use a certain LLM in let's say, Microsoft Azure, but then the fine-tuning would be done somewhere else.
Hey everyone, my name is Aparna, founder of Arise, and the best way to stay up to date with MLOps is by subscribing to this podcast.
Just because of the capabilities that's being available here or there, that's not unified across the different layers. So there is a need for one layer that's going to connect between all of these. Kubernetes was successful at the infrastructure level, but if we take it one abstraction level up, then there's another layer that's still being developed today by somebody. I'm keeping an eye, like if you hear of any, please do let me know.
Yeah.
Where we can build this unified infrastructure and machine learning platform that not only hides all of the details of which cloud you're running into, what capabilities that you're using, rather than it's only provides higher capability with the end business use case in mind.
Sure.
Which is what Kubernetes have done in this case when it comes to infrastructure and to cloud infrastructure.
Well, I love the idea of how Kubernetes has effectively enabled a whole ecosystem of tools that can be built and billion-dollar companies that are made because of what Kubernetes enables. And it feels like ever since the beginning of the MLOps community, one thing that we didn't have was that unifying open source project that all the rest of the tools can be built on, and there's no CNCF, maybe that's a little bit on me because I'm lazy and I didn't end up creating a big foundation that we could have all of these different tooling companies be part of. But it always felt to me like there was a hole, or we are missing some open source project that will help at least get what one of the creators of Kubeflow, when we talked to him, David Aronchik, you may know him from being around. Him. So he said that we need to create contracts with a small c. That was his thing, like not these hard requirements, but something where it is clear and you do have a way to plug into an ecosystem. The only thing is, I'm sure you've seen that joke or that meme where it's like, there's all these 12 standardization frameworks and nobody's using any of them. We need to create one that everyone's going to use. And then the next day, it's like, now there's 13 standardization frameworks that nobody is using. And so it felt hard to me to create something that would get that community involvement or that backing around and that everyone would adopt. And that is just like quite the endeavor. And so I think you do need the power of really big companies behind it that give their stamp of approval and say, we're going to support this and we're going to use this. And then you have a shot. But I'm excited about if that ever will happen. And I'm also a little bit weary. I think there is a need for it. I just wonder if it's going to be possible, right? Because what you're asking for is coordination from so many big companies that have their way of doing things.
It is possible. It's going to take time. But once all of the incentives align, and especially when it comes to pushing forward the current status of the machine learning world and AI world, things are going to change. So, we have several open conversations today when we talk about AI and the current status of the AI world. One of them is around regulations. Another one is around hallucinations and LLM. Third one around safety and security. Fourth is about privacy, but also about standardization. And when you look at the statistics, especially in the enterprise world, 90% of businesses around the world have made some investment in AI, have tried to find how they can use and leverage AI in their systems. But that statistics highlight that 15% of them is able to take their AI to production and make use of AI in their systems and infrastructures. So that just highlights the complexity of the world that we are working with, but also the gap that exists today between the capabilities that we have developed as an AI community, as a machine learning community, across the different fields, not just in natural language processing or not necessarily in LLMs or not necessarily through the current generative AI boom, rather than in all types of deep learning, specifically in what's going to bring the powerful use cases to the enterprise and move forward the state of the art in order to be able to actually save lives, cure diseases, be able to provide the economic acceleration that AI can provide for our economy and our systems around the world.
I guess when you look at the parallels again between the cloud and the AI, nascent AI movement that is happening right now, Kubernetes didn't come out, right, until 2016 or 17, if I remember correctly. It was maybe 2015, I can't remember, but all that's to say that the cloud had been around for a few years. And so potentially the Kubernetes for the ML and AI movement is still a year or two out because things need to settle a bit more before you can have that unifying layer be brought to the surface.
I would say it started somewhere around the thinking, at least the ideas started shaping around 2013, 14. I remember very well an email that Craig McLuckie sent to the product management internal list. There was also like few people on this list back then of, some of the early ideas. At that time, independently, I was writing a patent on virtualizations of virtual machines, of how we can build another layer of the virtualization. So I shared this patent work that I was doing with him. The patent later was awarded to Google with my name on it. So, I believe Google have used it, as far as I know, to be able to commercialize Kubernetes later on. So it was basically ideas were forming very early, and there was some exchange in 2013, 2014. So in this sense, I think the ideas are already out there today for Kubernetes for machine learning, or the machine learning abstraction layer that's going to provide the orchestration, similar capability to what we have seen with Kubernetes back in the days, as it provide the abstraction level for cloud and for the multi-cloud. Nonetheless, it's not going to be successful until we can see the use case, and the use case is still early on. So with how fast AI is moving nowadays, it might be like next year, it might be next week. Nobody knows, but it's definitely an exciting time.
Well, one thing that there is no shortage of in the AI and really data space are orchestration tools, right? I can name probably 5 or 10 just off the top of my head. But what we're talking about isn't exactly an orchestration tool, right? It's a little bit deeper than that. It's more of a way for you to plug your system and your tool and your environment into a layer that is compatible with, hopefully, a lot more layers. So you can have your node and you plug into the greater good, whatever that may be, and you know that everything's going to work because everything is standardized to that greater good.
Exactly true. I mean, think about it today. In order to do feature engineering, you need to use one system and then plug it into another system in order to do the training. And then depending on which training environment that you're using, then you need to, integrate it with different kind of environments, but also then you need to go into the inference, which supposedly could be on the same cloud or on a different cloud, and it comes with different trade-offs, but then you have to move to another cloud, and when you move to another cloud, then you will need different monitoring tools, then you will need different production system characteristics in order to be able to deploy your machine learning operation capabilities in order to make sure that the system is operational. But then once the system that's operational becomes the model degrades, which is, like a given in any model because of the changes in data distribution, at least that would be one reason. But basically you go back and you'll be, start the journey all again using different tools. So there is no unifying component between all of these. And while it's much better than developing machine learning models in C and pointers, I agree. But it's also the case that the more simple and streamlined the end-to-end process is going to be, the easier it is to be able to integrate it into other use cases, to bring it to more production systems and to more user-facing applications. And that's all going to advance the way that we are all doing and building and scaling machine learning for the next set of applications that's going to come out.
Yeah, and one other point that I think about when you talk about that headache of developing or basically getting something into production is how if a tool that you have chosen to use then gets deprecated, and then you have to go and figure out how to rip out that and then get a new tool that it actually works better, or companies move away from supporting open source projects, and what happens when you bet the farm on using that, or there's a breaking change and a new update of the open source project. So figuring out all of that is added complexity, and it would be like, I understand the dream, the utopia of having this. I do wonder who and how it's going to be created, right? Because it would be super useful to have. I just think that you would have to have somebody that can get everyone to play nicely with each other.
True. I mean, let alone, of course, experimentation, which is another, kind of works in terms of how you manage it and how you scale it. And agree with you. I mean, it's an opportunity if you'd like to see it this way.
Yeah, totally. You have to have a incredible diplomat take on the challenge.
Yes,
that's what I think it would be.
But it also it actually is in this white space between strategy, technology, and market, where you find the real opportunities and where you find the real exciting, challenges, if you'd like to say. So this is more of a strategic angle of what's going to happen in the next 2 years in AI and machine learning, and how can we bring AI and machine learning capabilities and tooling and models to wider audience, and specifically to enterprises who are going to be able to integrate it, because otherwise they're going to be disrupted, they're going to lose their businesses. But also, how do we move forward the whole field? So as I started my story about the typewriter, I mean, the typewriter job went away.
Yeah.
And now, we have computer. I mean, you never hear of somebody typewriting their dissertation anymore. I'm glad, especially if they have kids, of course.
Yeah.
But it's also the case of evolution and the case for moving forward of how can we move the whole field forward by providing better standardization, by providing better strategy, by bringing together the big players to address the very difficult questions that is challenging for the entire field today.
So there is one other piece too that I think is a symptom of the complexity that you laid out and the pain points. And that is how I've been seeing quite a few people, especially that are leading product. They say, oh, that whole mess that you talked about of trying to get, we'll say, quote unquote, classical machine learning model into production, we can bypass that whole thing if we just hit the OpenAI API. And we can just add that into our product, and we don't have to think about all this data pipeline or data cleaning and all of the hard parts of getting machine learning into production. And so it feels like they almost bypass that in a way, and you see that being incorporated into products and their offerings. But I also am very aware that not everyone can do that because of regulation, or they have some constraint around being able to send data out or just bring some API into their feature set or into their product. And B, what I feel like is people iterate really quickly. They test out their product features with that, but then you get to a point where you want more control and you want to be able to better manage and have more reliability with that feature set. And so what you're getting from OpenAI when they update their model and all your prompts go sour, or they are down for 24 hours or they have their rate limit and you have to figure out some hacky way to go and create a million different AI or OpenAI keys. And so I do notice that when you get to a certain level of maturity, after you've proven out that new feature with AI and you've basically skipped the line, you then realize, okay, now let's bring it in-house. And when you bring it in-house, then you eventually have to go through all those challenges like we talked about. So I do feel like, but at some point, or I should say on the other side, some people don't ever hit that level where they need to bring it in-house.
Mm-hmm. Correct. Absolutely. First of all, I should say how grateful I am for OpenAI and ChatGPT last November when they brought forward the ChatGPT interface and change the conversation or around AI and change the conversation. I mean, basically, we came from, this is science fiction. This is only, like the movies that we see in the movie theater, to a conversation in every dinner table of, everyone's, thinking about what ChatGPT can do for us and what APIs and what OpenAI is doing. And this is the future. This is where, things are going. So in this sense, we have taken the conversation, OpenAI releasing ChatGPT, taking the conversation and help the entire team, the entire field to be able to move it to the next level, to be able to have more intelligent conversations around what AI can do for different use cases. I would say, that was the point that we were able as a field to go from summers and winters beforehand to, it's real, it's coming. And finally, we can have real conversation about how do we basically build an ecosystem and address all of the different questions that are open about around AI. Having said that, I agree with you. It's all about the use case at the end of the day. It's all about the product development. It's all about the end user. And it's all about having a good understanding of the trade-offs that are available to us today by using APIs versus building our own system versus the actual implications / capabilities that we need for a specific use case. So when we talk about health data, for example, and privacy implications and HIPAA compliance requirements for health data and how we can integrate this and some of the LLM capabilities into healthcare environments, then it's a different conversation than where we're talking about question and answering services or a question or summarization even capabilities for public data or for Wikipedia pages. So basically having a good understanding between this and that, as well as between the different product phases and product development use cases, is going to help us also being able to address and help the rest of the basically deployment of machine learning across different verticals and different use cases. One of the things that comes to mind right away is specifically for startups, for example, who want to build products and iterate very quickly in order to be able to bring them to market. Their challenge, their trade-offs are very different than when we're talking about SMBs or Fortune 500 who are building products. So when we come to startups, it's very critical for time to market. It's very critical for them to iterate quickly on the product at low cost as possible. So when we tell them about building an LLM from scratch, or even, like using Llama, of course, have changed the landscape quite a bit since the release a couple of days ago. But basically, their focus should be time to market. Their focus should be get to the user, iterate as fast as you can, be able to validate the use case and get to product market fit. But once you are at product market fit, then it's a question of scalability. It's a question of other consideration, including privacy and user privacy. That's also the case with Fortune 500 from the get-go, because they have also some compliance and privacy requirements that might not necessarily be addressed with a API access kind of LLM.
Yeah.
So it's use case specific. The goal here is to provide as much information and educate, which is something that we're doing at JazzComputing in order to be able to bring this forward and in order to be able to enable the investors, to enable the product managers, to enable the executives at large organizations, but also startup founders to be successful in building and addressing specific use case for AI, which is what we all want, is to advance that state of the field.
So tell me more about JazzComputing, because I wanted to touch on this a little bit.
Absolutely. So we're very early stage at this point. We are a new kind of firm that we're building for creating the connective tissue between investors, Fortune 500 and SMBs, and then between startups. What we have found is that in order to move the whole field forward, we need to exchange information and provide good understanding, good foundations for the three players, the three sets of players in the market, in order to be able to make them play together, improvise together. I know you're a big music person. We're playing the guitar.
What gave you that idea?
Myself. So how do we bring all of these different instruments together in order to be able to move the economy forward with the help of AI? So let me give you a specific example. Fortune 500 and SMB companies, they know that AI is going to disrupt some of their use cases, but they are lacking the knowledge of what use cases in their systems that needs to be addressed, how can they integrate AI, and what's the organizational, technology, and strategic capability that they need to acquire in order to be able to address all of that. So we help them by understanding some of this, upcoming disruption, and how can they protect themselves and being able to evolve as a company in order to be able to get to the next level. Investors, on the other side, they also want to invest in AI. They want to increase their, basically enable good AI companies in order to be able to see where they can help with good investments, good returns for their LPs. So we help them also with forming and evolving their investment thesis, but also through some educational tools, through some advisory services, and being able to evaluate and due diligence some of the AI companies that's coming their way. Some of them are built on solid foundations. Some of them does not have the same solid foundations as others. So basically leveling the playing field to a great extent. And then the third player in this case is the startups, which are developing very, very sophisticated technology, but they might not necessarily have all of the capabilities around them in order to be able to take the product to market, specifically marketing, specifically what investors look for, specifically around what do we need to raise? I mean, cost structure. What does cost structure mean for us, especially from a technology point of view? Being a technical person myself, this was an eye-opener for me when I went to Stanford Graduate School of Business. So this is another area where we kind of, help them and connect them with the investors in order to be able to build this ecosystem and push the whole use case forward, but also connect them with large corporations that are going to be able to help them put their technology that they have developed into use cases and be able to distribute and be able to build their distribution channels. So this is the white space where we want to play in, and we today are playing in very early stage. We're still defining what's our product market fit. So we're experimenting and we're learning a lot, which is something that I love. We have a newsletter, we have a podcast, we have weekly announcements on our LinkedIn and on our website. We have several market research papers that's already published. We talk, our team goes and gives talk around the world in order to be able to increase this understanding of the trade-offs, similar to what we have said, like just discussed on open AI versus building our own LLMs, and be able to advance the whole conversation to the next level. And this is our goal. This is our mission.
Incredible. We'll leave all of those links to the great stuff you're putting out and all of that awesome content in the description in case anyone wants to check it out. Otherwise, it is JazzComputing. I love the name. It's hard to forget that one. As a huge jazz fan myself,
Nice.
You kind of picked it out. You probably saw the guitar in the background, or maybe you've seen me making a fool of myself on the internet before.
It's music, and music is amazing at how it kind of brings together, especially for jazz, being very different than other types of music, where usually they don't rehearse jazz improvisations beforehand, rather than they just discuss few, like 5-minute things.
Yeah.
But then as soon as the band comes together, every one of them plays a different instrument. It all comes together, they improvise, and then it's a beautiful piece. Not always, but most of the time. So similar to how the ecosystem can work together, and I think will work together in order to be able to improvise the next advancement in AI and machine learning and the acceleration of the whole economy using this new, and get rid of some of the typewriter stories we had, right?
So good. Well, thank you for coming on here. And I got through about 2 questions out of the 10 that I wanted to ask you. So I think we may have to have a part 2 on this.
Demetrius, it was such a pleasure meeting with you today. I loved our conversation.
Hey, I'm Vishnu. I'm a data scientist at Firsthand, and I definitely think that you should subscribe to the MLOps Coffee Sessions podcast. It's the best podcast out there to stay on top of what MLOps actually is, to talk to the true thought leaders in the space. And oh, by the way, Demetrios is absolutely hilarious. What a weird guy. You should definitely subscribe to the podcast.